This is questions 3B and 3C from the 2019 Functions Tech Allowed SAC. Okay, so the same mound had the following termite data. Develop an exponential model. Okay, so I might use my calculator to develop the exponential model. I've now got population based on height. So height is now my independent variable, whereas height up here was my dependent variable. Okay, so I've rearranged that. So if I go calc regression, I've got two choices. I'm going to use the exponential regression. That will give me base E. If I use AB, I get a base which is base B, or base A. I think it's base B. So exponential. So the rule will be 0.115 e to the power of b, which is 0.629 t. And that's my population equation. And that's h for height, not t for time. Okay. So I've entered that to 3 decimal places, 0.115 e to the 0.629x. When x equals 1, just to double check my rule, 0.21, which is 0.21. And when x equals 3, I should get an answer which is 0. So that's not quite as accurate. And the last one, when x equals 5. And 2.67. So we can see that we're getting similar sorts of numbers, so that's an acceptable rule that I will accept. Then how many termites would you expect them at after 10 years? Well, this is population to do with height. So I'd have to go back here to find out what is the height after 10 years, and then take that height and place it into this rule. So I might take this one here, which is the rule that I developed over here, and after 10 years, that gives me 5.51, and if I take that and place that into this rule, that's going to give me 3.77 should be the population when we're after 10 years. So 3.777, and if we're doing to 3 decimal places, 3.778 million.